On this section, I'll be covering parallel and perpendicular lines. And again, I'm hoping that this is all reviewed from algebra. Let's draw a Cartesian plane here. If I draw a line, and if I draw a parallel line to that, then that means if these two lines are parallel, we know from geometry that these angles have to be equal. They both have to be the same angle. And since the slope is related to the angle of inclination, remember that tangent of the angle of inclination is going to equal the slope. Right? But since both of these have the same angle of inclination, that's also going to mean that they're going to have the same slope. Okay, so that's the characteristic of parallel lines. So if two lines are parallel, they have the same slope. Okay, so once given the 2 points, of one of those lines, or you can know 1 point and the slope of that line, you can also find the slope of the line parallel to that one. Okay, because they have the same slope. Now, what happens when two lines are perpendicular? You might already know the relationship of the slope for perpendicular lines, but I'm just going to show you why that's going to be true. Let's say I have a line like this, and let's say I have another line that is perpendicular to this, like that. Right, so the angle of inclination for this red line right here is going to be that angle. And the angle of inclination for the blue line is going to be this whole angle, but this angle, because they are perpendicular, this angle is 90 degrees. Because the blue and the red are perpendicular. That means the whole angle is going to be 90 degrees plus theta. Now, using this rule, tangent of theta, tangent of the angle of inclination will give you the slope. You can say that the angle of the slope of the red line is going to be tangent of theta. So that's the slope of the red line. For the blue line, we're going to be having tangent of 90 degrees plus theta. That's going to be the slope of the blue line. Now we can simplify this. If you remember, tangent and the cofunction, cotangent, let me use this area on the left here. So just a reminder, cotangent of theta equals tangent of 90 minus theta. This is the relationship, or 90 degrees minus theta. This is the relationship between cofunctions. They, if the angles inside them are complementary, then the two functions are equal. This is also true for sine and cosine. Sine of theta is going to equal the cosine of 90, or basically what I mean by 90 minus theta is the complementary angle of theta. Okay, so using that rule, I can rewrite this tangent of 90 plus theta as 90 minus theta. So because I have 90 minus some angle here, using this property right there, that's the same thing as cotangent of this angle, which is negative theta. And cotangent is an odd function, so the negative comes outside, cotangent of theta. And cotangent is a cofunction of tangent, but it's also the reciprocal of tangent. So that becomes 1 over tangent theta. So this is the slope for the blue line. And if you compare it with the slope of the red line, they are negative reciprocals of each other. And you've probably learned this in algebra, that perpendicular lines have slopes that are negative reciprocals. And this basically shows you why. So perpendicular lines have slopes that are negative reciprocal. You need to remember to do both negative and the reciprocal. Many students just do the reciprocal or they just do the negative, but they forget to do both. But to get the slope of the perpendicular line, you have to do both negative and reciprocal. Okay, so this is just finding the slope of the parallel lines and the perpendicular lines.